All right, let's dive into one of the most important ideas in all of algebra, polynomials. Now, I know that word can sound a little intense, but trust me, they're everywhere, from designing roller coasters to predicting the stock market. We're going to deconstruct them piece by piece, so by the end of this, you'll see exactly what makes them tick.
So, you're looking at your textbook and you see something like this. At first glance, it can look like a total jumble of symbols, numbers, and exponents. It just feels complicated, maybe even a little intimidating. But I promise you, there's a really simple, really elegant logic hiding in there, and we're going to find it together.
So, what does this even mean? You know, like any complex code or big machine, the secret is just to understand the individual parts. We're going to take this thing apart piece by piece, look at the terms, figure out their power, and learn how to put them in order. It's going to make perfect sense. Okay, so to get a handle on the whole thing, we have to start small. We've got to start with the absolute most fundamental building blocks. Think about it, right? You've got to learn the alphabet before you can read a sentence. So first, let's learn the letters of algebra. And that first, most basic building block is called the monomial. It's just a single term. It could be a number like 5, it could be a variable like x, or it could be a mix like 7x or negative 5y squared. Just think of these as the individual Lego bricks of our algebraic structure. Each one is a solid, self-contained piece.
So, if a monomial is a single Lego brick, what's a polynomial? Well, it's what you get when you start snapping those bricks together. You just connect one or more of these monomials using plus or minus signs, and voila, you've built yourself a polynomial.
And here you can see it, plain as day. On the left, you've got those individual bricks, the monomials. And on the right, that's the finished structure, the polynomial, which is just a few of those bricks connected with plus and minus signs. That big, scary expression from the beginning, yeah, it's just 4 of these little bricks linked together. See? Not so bad.
Okay, so now we know what these things are made of, but how do we describe them? How do we classify them? Well, one of the most important ways is by figuring out their power. And for that, we use this idea called the degree.
Let's go back to one of our single bricks for a second. 3 times x to the power of 4. The power we're really interested in here is that tiny number up top, the exponent. And in math, that is a very specific name. That exponent is what we call the degree. It's that simple. For 3x to the 4th, the degree is 4. Now, that's pretty straightforward for just one term. But what happens when you have a whole chain of them in a polynomial and they all have different powers? Okay, let's look at a full polynomial again. We've got a few different terms here. We've got a term with a power of 4, another with a power of 2. So which one gets to define the degree for the whole thing? Which one wins? And the rule is actually super simple. You just look for the term with the highest exponent, the most powerful piece in the whole chain. That single term sets the degree for the entire polynomial. So in this case, 4 is the biggest exponent, which means the degree of the whole polynomial is 4. That's it. So we can identify the parts, we can find the degree. Now, let's talk about getting organized. You know, to make these things way easier to read and work with, mathematicians decided on a standard way to write them out. It's called standard form. And all you have to do is line up the terms from the most powerful to the least powerful. You start with the one that has the highest degree, and then you just work your way down. It's like putting your players on the field from strongest to weakest. It makes comparing different polynomials a breeze. And hey, once you've got your polynomial in that nice, neat standard form, that number out in front of the very first, most powerful term, it gets a special name, the leading coefficient. It's literally the leader of the pack. All right, we've identified all the parts, we've put them in order. Now it's time to actually do something with them. Let's look at the basic rules of the road for adding and subtracting these things. This right here is the golden rule. It's the one thing you absolutely have to remember for adding and subtracting polynomials. You combine like terms. So the big question is, what in the world are like terms? It's really just a simple 3-step process. First, you look for terms that are alike, meaning they have the exact same variables and exponents. So an x squared term can only be combined with other x squared terms. Then you just add or subtract the numbers in front of them, their coefficients. And finally, you just write out your new, cleaner, simplified polynomial. Oh, and by the way, just a quick vocabulary boost. You're going to hear these words a lot. A polynomial that has exactly 2 terms is called a binomial, you know, like a bicycle has 2 wheels.
And one with 3 terms? That's a trinomial, like a tricycle. They're just handy shortcuts to say how many monomial bricks you're looking at. So we've deconstructed the language, right? We know how to identify the parts, how to organize them, and even how to do some basic math with them. So what's next? Where do we go from here on our algebra journey?
Well, the next big step is often taking these abstract expressions and turning them into a picture by graphing them. And let's be real, this can definitely be a challenge. But it's also where all these ideas, like the degree and the leading coefficient, start to really come to life and show you the actual shape and behavior of these things.
But here's the cool part. Think back to that intimidating expression from the very beginning. It's not some secret code anymore, is it? You know what a term is. You know what the degree is. You know what the leading coefficient is. You have the tools, the building blocks. That next challenge is waiting, for sure. But now, you speak the language.